You've stated that you believe there could be an infinite number of parallel universes. Does that mean that there is a universe out there where I am smarter than you?
Yes, and also a universe where you're funny.
Dr. Asimov, most people, when they think about the future, try to reach out to the year 2000. Let's try 500 years from now. What kind of planet do you see?
One of two, depending on what happens by the year 2000. If by the year 2000 we have not solved the problems that face us today, then I would say 500 years we'll see a world containing a technological civilization in ruins, in which there will be a relatively small number of human beings sort of surviving, and with New York City as the most magnificent ruin in the history of the human race.
And the other is? If we
succeed in solving our problems today, then 500 years now we can well be living in a kind of utopia, a world with a relatively small population, carefully husbanding their resources, with a working colony on the moon and perhaps on Mars, reaching out to the entire solar system, taking advantage of advances in technology we now can't even imagine, living under conditions which, when they look back on the present, they will be horrified and wonder how we could have survived.
I have experienced plenty of things which could be called transcendental. I've experienced the feeling of almost mystical wonder that I get when I look up at the stars, look up at the Milky Way, contemplate the galaxies receding from us, listen to a Schubert quintet, read a sonnet of Shakespeare. These are all things which only a human mind is capable of doing.
So may I ask you? Okay, sorry.
Only a human mind is capable of doing that. And a human mind is capable of doing those things because the human mind has been put together in the brain as a highly complicated organization that has evolved over some 4 billion years of evolution, putting together nervous systems. It is a stunning achievement of evolution to have put together the human brain that is capable of being moved by such things. I yield to no one in my capacity to be moved by what you call the transcendental. What I do not do, however, is to indulge in mystical nonsense about it being there before there were brains, or the equivalent of brains.
We got the Big Bang. That's been going for a while. Now, not everybody's happy with the Big Bang. You found this billboard. So apparently, God isn't happy with the Big Bang. I would have thought he'd be totally cool with it, but apparently not. I found this bumper sticker in New Mexico. The Big Bang Theory. God spoke, bang, it happens. This one is okay with the Big Bang, but that God did the Big Bang. So people are still trying to wrestle with this. Here's what we know. This is the entire universe in one slide. Quantum fluctuations, birth, an entire explosion, rapid expansion, we call it inflation. That's an idea that came about in the 1970s when there was inflation, severe inflation in our economy. So the word had a lot of currency back then. Now it's like you're inflating a tire, like what are you doing, you know? There is the baby picture of the universe. That's that sort of aqua surface there. That's sort of the imprint of what happened in the very earliest moments, writ in the background sky. There it is, the cosmic microwave background, a record of the earliest moments of the Big Bang. Then it takes a little time to make your first stars. We call it the Dark Ages. Stars are made, galaxies mature. We come up to the present day, 13.7 billion years later, and that telescope, we can't see the whole name, it's called WMAP, Wilkinson Microwave Anisotropy Probe. They clearly didn't want anyone to pronounce that or remember it. I would just call it the Big Bang Machine. That made this measurement. And so it's a pretty coherent picture that we have of the origin of the universe. And here's that map that the space probe shown. And so this is a record of the earliest moments of the universe. And it tells us what the universe was up to. And data agree, we're all pretty happy with this, and we're kind of moving on.
The scientists that I respect are scientists who work hard to be understood, to use language clearly, to use words correctly, and to understand what is going on. We have been subjected to a kind of word salad of scientific jargon used out of context with inappropriately, apparently uncomprehendingly. There is a deep confusion going on here between the properties of things within the universe and the properties of the universe itself. It is one thing to say that the universe contains objects that have sentience and the various other properties that you mentioned. Of course it contains objects that have sentience. We are among those objects. So are dogs. So are chimpanzees. The universe contains sentience. The universe is not sentient. This is the one thing, Deepak, you seem not to understand. You're constantly confusing explanations at the level of what goes on inside the universe with the universe itself. It's not enough to say the universe contains sentience, contains purpose, etc., and say, therefore, the universe is sentient, the universe is purposeful. Evolution, you say, has a purpose, diversity, because what we see is diversity. Of course what we see is diversity. That's the consequence of evolution. But you mistake when you think that evolution is driven towards it.
Time is over. Un applauso.
It's a beautiful picture from the Hubble Space Telescope of a distant galaxy, far, far away and long, long ago. And there's a whole galaxy, it's about 1 billion light years away. We're looking at it as it looked 1 billion years ago. So many of those stars no longer exist. And here's an object that's just as bright as the whole center of the galaxy. You'd think it's a star that's near in our galaxy that just got caught in the picture frame. It's not. It's a star on the edge of that galaxy that has exploded. And exploding stars shine with a brightness of 10 billion stars. They're the brightest fireworks in the universe, supernovae. And they're remarkable, and I keep having asides. Maybe I'll get to my point eventually. But this is something that I wrote a whole book about, and someone asked me yesterday why I wrote that book. Because it is the most poetic thing I know about the universe. Richard wrote a great book called, what's it called? Our Ancestors? What's it called? Ancestor's Tale, yes. I wanted to make sure I got that right. And I wrote a book that was a different Ancestor's Tale. It was called Adam. But the amazing thing is that every atom in your body came from a star that exploded. And the atoms in your left hand probably came from a different star than your right hand. It really is the most poetic thing I know about physics. You are all stardust. You couldn't be here if stars hadn't exploded, because the elements, the carbon, nitrogen, oxygen, iron, all the things that matter for evolution weren't created at the beginning of time. They're created in the nuclear furnaces of stars, and the only way they can get into your body is if the stars were kind enough to explode. So forget Jesus. The stars died so that you could be here today. Okay? And anyway.
If you look at the chemical ingredients of life itself, you remember from biology class, we're mostly water. And good old water is H2O. 2 hydrogens, 1 oxygen. And if you could look at the sort of the element budget of life, hydrogen is number 1, as expressed in the water molecule. The number 2 in the human body is oxygen, turns out. Number 3 in the human body is carbon. 4 is nitrogen. 5, you find on all lists, is other. Okay, now if you go to the universe, that's the O on the periodic table. You didn't know that? That's not for oxygen, it's for other. So, you go into the universe, number 1 ingredient in the universe is hydrogen. That was true in life. Number 2 ingredient in the universe is helium. We don't have that one.
It doesn't like anybody.
No, how come? Well, because helium is chemically inert. You can't do anything with it even if you wanted. You can inhale it, okay? And sound like Mickey Mouse, yes. Next in the universe is oxygen. Next, carbon. Next, other. Thank you, in the 3rd row there. So, actually that was the 2nd row. They must be related to the 2nd row here. We are 1-for-1 matchup with the most abundant ingredients in the universe. Of these, carbon is the most chemically fertile element in the entire periodic table. You can make more kinds of molecules with carbon than all other molecules combined. So, if you were going to experiment through the forces of nature with complex chemistry, and you had to pick an element to base it on, carbon is your man. Or your woman, however that goes. Okay, so what I'm saying is, given what carbon is capable of doing, perhaps we shouldn't be so surprised that there's life, because we are carbon-based life. We're just another one of the things carbon has rolled up its sleeve. Maybe life is inevitable, given the abundance of carbon and oxygen and nitrogen and hydrogen in the universe. Try to invert that view. Otherwise, you're left thinking, hey, we're special. You know I would give you right to say you're special? If life on Earth were made of an isotope of bismuth. That stuff is nowhere in the cosmos, and then we're made of it, we're special. Okay? But if we're the most common ingredients of the matter that we know and love, you don't have an argument.
Hawking has said he believes in the creative majesty of scientific law, not a personal god for humans.
When you look at the vast size of the universe, and how insignificant and accidental human life is in it, that seems most implausible. There is a fundamental difference between religion, which is based on authority, and science, which is based on observation and reason. Science will win, because it works.
My attitude to science is that we are fundamentally trying to understand how things work. Science is very difficult. It's very difficult to understand how things work. The hard problem of consciousness has been mentioned, the problem of the origin of the universe, the problem of the origin of life, the problem of how life has this uncanny appearance of being designed, the size of the universe, the scale of the universe, how embryology works. These are all deeply difficult questions. They require hard scientific work, and in all cases, I think I'm right in saying that scientific work consists of explaining complicated things in terms of the interactions of their parts or of simpler things. So we always try to explain complex things in terms of simpler things. We do not resort to magical language. We do not snow our audience with highfalutin sounding words that don't actually mean anything. We use words that actually have meaning. We use expressions that can be tested. We work hard at understanding the universe in terms of its component parts. We don't invent superarching entities which have no explanation in themselves. We don't invoke ideas like the universe has consciousness, the universe has awareness, atoms have awareness. If we have a difficult problem like awareness, we explain it in terms of the interactions between small parts working together in ways that scientists understand. If Freeman Dyson ever said atoms are aware, then he's wrong. I don't think he said it. I think he should sue you.
Wow. The fact that pi, right?
Let's say the numbers together. 3.1415926.
We got a few.
That's pretty good. That's a nerd fest.
We got a geek thing going on over there.
Not bad, not bad.
The fact that you take a circle of any size, a circle the size of the universe itself, and divide it by its own radius, and you get that number, that's beautiful. I have to pause, and I get misty thinking of this. It's not, that's just another one, that the atoms and molecules in your body are traceable to the crucibles in the centers of stars that manufactured these elements over its lifespan, when unstable, on death, exploding its enriched guts across the galaxy, scattering it into gas clouds that would ultimately collapse and make a star and have the right ingredients to make planets and people. Which means we are part of this universe As I've said many times, and this goes back, not only are we in the universe is in us. That is a profound concept, and I think it's the greatest gift that astrophysics gave culture in the 20th century.